Hey guys, what's going on? Welcome back to another video. In this one, we're going to be actually starting a brand new series called Go Concurrent, as you can see. And essentially what we're going to be doing is I've been learning about how to use or how to write concurrent code properly in Go. And I figured as I'm learning that, I would teach it to you guys because I want to help out, but also it helps me to learn and really understand things a lot to actually, teach the material as well. So I've been told that I talk too much as part of the intros, so we're just going to get right into it. This is going to be a new series. I am guaranteeing at least one video per week. However, there might be more than one video per week. And what we're going to be learning is what is concurrency versus parallelism. As a matter of fact, in this first video, we're going to be discussing the difference between the two. Then we're going to be learning about the challenges with concurrency. Then how the scheduler actually works. This is really, really amazing. At least I find it really amazing. So we'll definitely get into that in a lot of detail when we get there. Then we'll talk about how to actually model and structure our code. We'll talk about the the building blocks that the Go language has, or the Go tools, to be able to write concurrent code properly, as well as some patterns. And finally, we will get into scaling our code, or making sure that our code scales, right? So something really, really important that I want to talk about, which is what we're not going to be learning. We're not going to be learning the Go programming language itself. So if you don't know Go, maybe start out with learning Go. If you know how to program with lower level languages, then I think you'll still be able to get it, through this series. You shouldn't really have any problems, but just know that we're not going to be going through what things are in the Go programming language. We're really just going to be focusing on the concurrent aspect of things. So just to kind of define what concurrency is, it's one of those things that means different things to different people. And so you might have heard some of these words kind of thrown around. We have asynchronous, we have threaded, we have parallelism, and then of course you'll hear concurrency thrown in there as well. And the question is, well, are these all the same thing? Are they different? Are they related? Are they not related? What's the deal here? Well, the truth of the matter is that they are related, but they're not really the same thing, as we'll see in a minute. So first, let's define what parallelism is, because parallelism, I think, makes more sense from a conceptual standpoint, right? So parallelism is, as the name implies, when two or more units of work or tasks are actually executed and running at the same time. Actually, they don't have to be executed at the same time, but really it's when they're running at the same time. So we have two units of code, right, or two tasks, and they're running at the same time on the same computer next to one another, right? That's kind of how we can think about it. So let's view parallelism, right? So this would be what the actual visual representation of this would be. We have processor 1 on the top, and we have processor 2 on the bottom. And these could also be like different cores. If you have a single processor, well, most are single processor, multi-core, but we have different cores or whatever, two different processors, and we have two different tasks. And each of these two different tasks are, maybe they're executed at the same time, maybe they're not. It doesn't really matter, but they're running at the same time on the same computer, just on different logical processors. And we'll get into what that means in a later video. Specifically when we talk about scheduling, we'll talk about logical processors. Now let's talk about what concurrency is. And it's a little bit different. The first part of the definition is the same thing, but it actually ends up being a little bit different in the end. So concurrency is when two or more units of work or tasks can be executed or can be running in an overlapping time, right? An overlapping space of time. So let's say we want to visualize this, right? How would we visualize this? Let's say this unit of time right here, this gray block. Let's say that's 1 second, for example. And each of these smaller blocks within that gray block is a task or a unit of work that we want to execute. Now this could be, let's see, maybe a function call, or it could be to go and request from an API somewhere, like a third-party API externally to our code. It could be accessing a database. Could be a lot of different things. So what does that mean? This means, concurrency means that within this 1 second, we can execute two or more different tasks at the same time, or have them we can run them they're not running at the same time, but they're executing within that same period of time. Instead of saying, no, actually, if we have two tasks, we need to run for the first 500 milliseconds or half a second. We need to run the first task, which would be, let's say, all of the blue squares here, and then in the following 500 milliseconds, or the last half second, we're going to run all of the orange or yellow, depending on how you see that, squares at the back, right? Instead, what we do is we say to the scheduler, hey, we're going to give you the ability to decide what should be run and when it should be run and how it should be run. This is what concurrency is, okay? Concurrency can speed up your code, or the execution of your code, a lot. But if you don't know how to do it, if you don't know how to use it and you don't use it right, it can also hurt you and slow down the execution time of your code. And that's part of the what we're going to be learning about and answering in this series. So concurrency, it doesn't guarantee anything. As a matter of fact, this right here, if we're viewing only concurrency, this could end up where all the blue ones execute first and then all the orange ones do. It could also end up that there's a different order of the blocks here, not with the 2 blue, 1 orange, 1 blue, 1 orange, and so on. It could start off with 2 orange, for example. It really doesn't matter. We tell the scheduler, hey, we're going to allow you to do this, to break it up if you see fit, and the scheduler figures out how the code can most efficiently be run. Next, it simply gives this is what we just talked about actually. It simply gives the scheduler the option to run different pieces of code within the same unit of time. And this is actually all that I have. So this was kind of a short video. I just wanted to introduce this series, and I also wanted to explain what concurrency is, how it differs from parallelism, because you use them both in Go, or you can potentially use them both in Go. Certainly, I would imagine you'll use concurrency, while not all the time, more times perhaps than parallelism. And we'll definitely go into why that is and certain examples of when that might be. But for now, again, I just wanted to give you guys the introduction. So if you're interested in this series or these kinds of videos, I've been learning Go. I use Go professionally now. And so I'm going to be coming out with a lot of videos on lower level stuff, more back-end stuff. That's really what I personally have the most enjoyment with. So subscribe, comment. If you have any questions, definitely comment down below. Give me a thumbs up if you're excited for this series. And I can't wait to see you next time. Also, today is January 1st, so I hope everyone out there is having a great new year. And hopefully 2021 is a good one. Take care. Peace.